So we have seen in the case of an horizontal oscillation of a loaded spring, time period is 2 pi root of m by k, where m is the mass of the load and k is the spring constant. Now consider another case. It's a vertical oscillation. Consider the same mass m is connected to the spring of spring constant k, but it is a vertical, and we are displacing this mass and it executing simple harmonic oscillation. We have to find the time period. In the last case, we have seen which force is responsible for this its time period. There are different types of forces. It may be constant or variable force. So we can look at its free body diagram. When we consider the free body diagram, the different forces acting on this block are its weight mg acting vertically downward. And if the block is displaced by a small distance x towards downwards, it will experience a restoring force in the opposite direction. So that restoring force, that is kx, if you are displacing this block by a distance x, it will experience a restoring force which is opposite to the displacement. So these are the two forces. Which force is constant and which is variable force? We know weight, mass is a constant and weight is a constant. So here the force mg or weight is constant. So the only variable force is kx. So this force is responsible for its time period. So we can consider this restoring force, that is minus kx. Restoring force is always opposite to the displacement, so that is minus kx. That can be equated to force that is equal to ma. From here we can write minus k by m into x is equal to acceleration. We know for simple harmonic motion, condition is minus omega square x is equal to acceleration. So comparing this equation with the standard equation, we get instead of omega square, we have k by m, and omega that is equal to under root of k by m. So in terms of time period, omega equal to 2 pi divided by t. So time period t equal to 2 pi root of m by k. So here also the time period depends on the mass and the spring constant. So what will be the oscillation, whether it is horizontal oscillation or vertical oscillation, its time period equal to 2 pi root m by k. So remember the point that only the varying force or variable force can change this time period, not role for this constant force. So when you are solving the problem related to this mass spring system, you just consider this variable force only. Okay.